One of the questions we're getting fairly frequently in the last year are complaints about high frequency noise from wireless transmitters, particularly these sort of dongle based units that plug straight into the base. I thought I'd take a few minutes and talk about how these work and some of the things that you can do to remediate noise issues. With a body pack like this, your transmitter is far away from the control cavity of your bass guitar. Mine would be in my back pocket or on my strap on my back, so far away from the electronics. So there's really not much risk of radio signal from this getting inside of the control cavity and generating noise. On the other side, these little units, when they plug in, they're literally right at the entry point to your control cavity, so the transmitter is right next to your electronics, so there is a lot higher risk of picking up radio frequency noise. And this is where shielding of your compartment is paramount. When you look inside your cavity, it should be painted with a conductive paint or fully sealed with a foil liner. If you're not sure, take a meter, set it for continuity, and touch multiple points inside the cavity along the walls and the bottom. They should read like a short circuit. If it doesn't, you need to make sure that cavity is fully insulated with a conductive foil or paint. This will help cut down noise. But the other issue with these type of transmitters is the plug. A normal guitar cord has a tip and a sleeve. It's a 2-conductor plug. A lot of the newer transmitters have a TRS, a 3-conductor, a tip, ring, and a shield. This presents a problem when you're using an instrument with an active preamp. I'll illustrate the problem using a stereo jack, which is an open frame version of what you would find in any instrument that has an active preamp. This jack has 3 connections on it. The long spring for the tip, the shorter spring for the ring, and then the inside piece is for the shield. This acts like a power switch when you plug a normal guitar cord into it. The tip is connected to the tip. The ring is connected to the shield, and also the shield itself is connected to the shield. So power coming in from the battery to the ring connector is shunted directly to the shield and back out the shield. So the ring and the shield act like a switch. And we can illustrate that by hooking up an LED and showing what happens. What I have here is a battery connected to a typical stereo jack connected to an LED. So when we plug it in, we'll see it light up, indicating that we've closed the switch. We're shorting the circuit between the ring and the sleeve, and that turns on the LED. Now, if I were to take a 3-prong jack like this and plug it in, what do you think is going to happen? Nothing. The ring connector is touching the ring, but it is not making it to the shield, so that circuit is not complete. So what happens when you plug in one of these? When you plug this transmitter into the jack, the signal comes out the ring, goes into the transmitter where some active circuitry determines whether you're actually connected or not. It makes the connection back to the shield. So you're taking that switch action from this jack inside of this transmitter. This is done differently on different transmitters. The Line 6 uses this little button right there that turns the circuit on and tells it to connect these two so it provides power to your preamp. Unfortunately, this is not a perfect solution. So let's do a test using continuity readings on our meter. So if we have continuity, it'll beep and you'll see the display says 0 ohms, meaning this is a perfect short circuit. So if we take our TRS jack, we plug a regular guitar cord into it, and we measure continuity between the ring and the sleeve, we've got a perfect connection. We have a beep, we have 0 ohms, that's a perfect connection. So what happens when we plug in our wireless transmitter with the TRS cable? Plug it in, you notice that it makes a little button on there. Can see it too well here, but the green light is on. So let's measure continuity. We have a beep, but look at our meter. 43 ohms. What's that telling us? This tells you that the battery ground is coming in from the ring inside the transmitter where all the RF noise is, through an active circuit that closes and sends a signal back to the shield so it powers your preamp. It's not a perfect connection, and this is how noise gets injected into your preamp circuit. So how do we resolve this? Two things. First, make sure your cavity is fully shielded, either with conductive paint or a foil shield. Use a transmitter that only has a 2-conductor plug instead of a 3-conductor plug on it. That'll save a lot of problems. If you must use one that has a 3-conductor plug on there, you can use an adapter like this one here. This is a little bit more cumbersome because instead of putting the transmitter on the base itself, it's now going to be hanging somewhere else, but it will get rid of your noise issues. So that's it. I hope that makes a little sense for people that are having unusual issues with their wireless units. If you haven't taken a chance yet, hit subscribe, and I will talk to you next time.